In this video, we're going to take a look at arc length and area of a sector. So let's review. We're going to find the area and circumference of this circle below. So the area of a circle formula is pi r squared. And so if you look at the circle they gave us a diameter of 4. And so the radius would be 4 divided by 2, which would just be 2 centimeters. So half of the diameter is our radius. And so when we try to find area, which is pi r squared, we just need to plug in the 2. So that would be pi times 2 squared, which we could leave as 4 pi, or we could find the decimal, and that would just be centimeters squared. For circumference, we need to find 2 pi times the radius, or pi times the diameter. Either formula would be okay because 2 times the radius is equal to the diameter. And so 2 pi times the radius, which was 2, which is the same thing as pi times the diameter, which was 4, will give us 4 pi square centimeters again. And that doesn't happen every time that the area and the circumference are the same, but for our example, they are. So not every time. So let's look at arc length and area of a sector. So the arc length is the length of an arc around a circle that's like part of the whole circumference, but not the whole thing. And so what we do is we say n over 360 degrees. So that arc measure of n divided by the total degrees in a circle, which is 360. And then we multiply that by the formula for the circumference. So I'm just going to put 2 pi r inside there, but it could also be pi times diameter. So a portion of the arc that would cover the whole circle. So like whatever your arc length is, you put over 360 and then multiply it by the formula for the circumference. For area of a sector, it's a portion of the area of the whole circle. And so we still have n over 360 for that portion of our whole circle that we're looking at. And then we just have to multiply by the area of the circle, which is pi r squared. All right, so let's take a look at some examples. For example 1, it says find the length of arc AB. All right, so we need the length of arc AB, so we need to multiply n over 360 times 2 pi r. So n is the measure of that arc. So 120 degrees is our central angle, which equals the measure of the arc. So we can say it's 120 degrees over 360 degrees times the circumference formula, which is 2 pi times the radius. And the radius in this case they gave us was 6. All right, so let's calculate. We have 120 over 360, which is 1/3. And then we have 2 times 6, which is 12 pi. And 1/3 of 12 pi would be 4 pi. So our arc length is just 4 pi centimeters. All right, example 2 says the length of arc EF is 5 pi. Find the length of the radius. So we have to work backwards. So if we know the length of the arc is 5 pi inches, we're going to fill that in. So first let's write out our formula. So let's put, I'm going to put L for length was equal to our formula in number 1. And I'm going to write arc length. So L is equal to n over 360 times 2 pi r. All right, so the arc length they gave us was 5 pi, and that's going to equal that measure of the arc, which is equal to the central angle. So we know that that's 30 degrees over 360 degrees, and then we're looking for the radius. So we leave the r in our problem. All right. So what we can do is try to simplify the 30 over 360. So 30 over 360 would reduce to be 1 over 12. And then we have 2 pi times the radius. All right, so then I would say 1/12 times 2 pi. let's just multiply both sides by 12 to get rid of that denominator. And so we get 60 pi equals, and then the 12 would cancel out, and we're left with 2 pi r. Then we could divide both sides by 2 pi at the same time to get rid of both of those, and then 60 pi divided by 2 pi would be 30 for the radius. So the radius is 30 inches, because inches was given in the original words of the problem. All right, number 3 says, the circle has an arc whose measure is 80 degrees and whose length is 88 pi. What is the diameter of the circle? So let's put the arc length is n over 360 times 2 pi r, that same formula. They told us the arc length is 88 pi, so let's plug that in. The arc measure was 80 degrees, so we're going to put that 80 degrees over 360 degrees. And then 2 pi times the radius, or actually let's just say that that's pi times the diameter. Since we're looking for the diameter for this problem, it would actually be better to use that formula. So they're the same formula. 2 pi r is the same as pi times diameter. So I'm just going to use that for my formula to save a little bit of work. Okay, so let's reduce 80 over 360. So let's see, if we cancel out the 0 and we divide each one by 2, we would get 4 over 18. So that would be, let's see, we could divide each one by 4. So if we divide by 4, we just get 2 over 9. And that would be easiest to reduce it all the way to 2 over 9. And then bring down the rest. So we have 88 pi equals 2 over 9 pi times diameter. All right, so let's multiply both sides by 9 and get rid of that denominator of 9. So let me pull up my calculator. And clear out what's in there. So let's get 88 times 9 is 792. So I get 792 pi equals 2 pi times the diameter. So I just need to divide both sides by 2 pi. And it's okay to do that all at once. And so 792 divided by 2 gives me 396. Because the pi would cancel out. And so 396 was the diameter for that one. So then we're finished, and that would be, I don't know if they gave us any kind of dimensions. Okay. Number 4, a circle has a circumference whose length is 25 pi. Find the length of an arc whose central angle is 90 degrees. All right, so if the circumference is 25 pi and circumference equals 2 pi times the radius, or actually, we could just skip that part because we can use the whole circumference and find, what are we looking for? The length of the arc. So remember, arc length is the measure of the arc over 360 times the circumference, which is normally 2 pi r, but they gave us that already as a 25 pi, so we could just plug that in. Plug in the 90 degrees for the measure of the arc, and that way we can just go from there. So 90 over 360 is 1 over 4 when we reduce it. And then we have 25 pi was the circumference, which we plugged right into that formula. All right, so then 25 pi divided by 4. So we could either leave it as a fraction or just get a decimal. So let's do 25 divided by 4 is 6.25 pi. And that would be it. All right, so let's look at some examples for area of a sector. So area of a sector is when you have like a piece of pizza. You're finding a portion of the area of the whole circle. So area of a sector is n over 360 times pi r squared. And so we have the 90-degree angle, which is the measure of the arc. Since it's a central angle, they're equal to each other. So we can say the area of a sector for this one would be 90 over 360 times pi r squared, and they gave us the radius was 16. All right, so 90 over 360 reduces to be 1 over 4. We can cancel out the 0, and we can see 9 over 36 is equal to 1 over 4. And then we have 16 squared. 16 squared. That would be, let's see, 256. So we have pi times 256. And then we could say 1/4 of that. In other words, 256 divided by 4 is 64. So we end up with 64 pi for the area of the sector. And we could put square inches since they did give us the dimensions. The units, I should say. All right, so B, we're still finding area of a sector. So we want the measure of the arc over 360. That gives us like what fraction of the circle we're looking for. So the 135 is the central angle, which means it's also the measure of the arc. Then we got to multiply by the area of the circle. So we're basically finding a fraction of the area for the whole circle. So we're saying 135 out of 360 times pi r squared, which they gave us was 8 for our radius. All right, so we can calculate. I'm just going to type in 135 divided by 360. But then I'm also just going to go ahead and type in the 8 squared. So I'm leaving it in terms of pi. Notice I did not type in the pi. I typed in everything else. So I've got to write pi as part of the answer. So it'll be 24 pi meters squared. All right. Example C. So we need to find area of a sector. We have the measure of the arc over 360 times pi r squared. That same formula. So our arc measure is 40 degrees over 360 because the central angle is always equal to the arc measure. All right, and then pi times 18 squared, since 18 was our radius. So I can type everything in the calculator, but I'm just going to leave out the pi again. So let's do 40 divided by 360. Oh, let me try to take away the extra parentheses down there. Okay, so 40 over 360 times 18 squared gives me 36, but don't forget to write the pi as part of the answer. So 36 pi meters squared. All right, let's look at another one. So this one says, find the radius of a circle which has a sector area of 9 pi and whose central angle is 90. So let's write out our formula. The area of a sector is n over 360 times the area of the whole circle, which is pi r squared. We're trying to find the radius, and we know that it has a sector area of 9 pi. So we fill that in. And the central angle of 90. So we fill that in for the n. And we can solve for the radius. All right. So 90 over 360, if we cancel out the zeros, it's like 9 over 36, which is 1 over 4. We've got pi r squared times 9 pi. So I'm going to multiply both sides by 4 to get rid of my denominator, get rid of that fraction. So I get 36 pi is equal to pi r squared. Then I can divide by pi and get rid of pi on both sides. So I get 36 equals the radius squared. And then when I take the square root of both sides, I really get plus or minus 6, but the radius can't be a negative. And so we just get positive 6 for the radius for that one. All right, and in our last example, we're looking at the central angle of a sector is 60 degrees. And the area of the circle is 144 pi. What is the area of the sector? So area of a sector is n over 360 times the area of the whole circle, the area of a circle. And they gave you that. So the area of the circle was 144 pi. And then we have the central angle of the sector was 60 degrees. So that means that's the measure of the arc. And then we can just put those together. So they saved you some work. And we got 60 over 360, which is like 6 over 36, which is 1 over 6 times 144 pi. So let's just type in 1/6 of 144, or 144 divided by 6 would be the same thing, which is 24. So the area of the sector would be 24 pi. And they didn't give us units for that one, so we can just leave it like that. All right, so keep in mind that arc length is a part of the circumference of your circle. An area of a sector is part of the whole area of the circle. And that'll help you with these problems. But that's it for arc length and area of a sector.